Welcome back, everybody. Today we are going to be talking about the binomial expansion. This is going to be the part that comes after the factorial portion of the, online studying that we did last time. So before you start this session, hopefully you did the factorial part, and if you didn't, please go back and check for it, because this is going to require that topic in order for us to deal with this then. So before I start on this binomial expansion thing, I'd like to give a formal definition that we're going to be using that's going to be helpful actually in this case. The notation that you're going to see is the following right here. N, and then you have a K, and they're both inside the parentheses, inside a column like this. The way that we word it is that this is the same thing as saying N choose K, so I can just kind of write that out. N choose K. So that's how you actually say it then. In terms of where this terminology came from, it's going to be something that we will see in statistics later on when we do probability then. But nonetheless, let's go back to this, theorem for the time being. Oh, sorry, definition. And here is what the definition means. When you have n choose k, that's the same thing as saying n factorial divided by k factorial multiplied by n minus k factorial. Okay, so to give you a numerical example, let's say that we have the following. Let's say that we have 5 choose 3 then. So written like the following. So then that means numerically this is equal to 5 factorial divided by 3 factorial multiplied by 5 minus 3 factorial. So what that equals to then is going to be 5 factorial divided by 3 factorial multiplied by 5 minus 3. That's going to be equal to 2, so 2 factorial. So whatever that comes out to be, that's going to be our answer. So if I remember correctly, the 5 factorial, that is supposed to be equal to 120. 3 factorial, that is supposed to be 3 times 2 times 1. So that is going to be equal to 6. And multiplied by 2 factorial, that's equal to 2 then. And, just to kind of show you where that 120 came from, again, that's 5 times 4 times 3 times 2 times 1. Whereas the 6, that is the result of 3 times 2 times 1. And the 2, that is because of the 2 times 1. So we just go ahead and clean this up then. So let's see here. So 6 goes into 120 20 times. 2 goes into 20 10 times. So the answer is equal to 10 then. Okay. So, as I said, we're going to need the factorial part of the mathematics in order to do this. So please, again, if you don't know the factorial, you might want to go back and relearn it then if possible. Okay. So now let's go ahead and talk about this binomial expansion thing that I was just mentioning. So when I'm referring to the binomial expansion, I'm talking about the following. Let's take an easy part first. Let's say that we have x plus y quantity squared. Now, according to FOIL, that is going to be equal to the following. That's x squared plus 2xy plus y squared. Okay. Now, if I ask you to do what is x plus y to the third power, saving you the time, you're supposed to do FOIL, and you're going to do this twice. So the result is going to be x cubed plus 3x squared times y plus 3 times x times y squared, and then plus y cubed. Let's go ahead and take it to one more level. Let's say that we have x plus y to the fourth power. Again, saving you the heartache of having to multiply everything out. What you're supposed to get is x to the fourth, and then plus 4 times x to the third y plus 6 multiplied by x squared, y squared, and then plus 4 multiplied by x times y cubed, and then finally plus y to the fourth. We could do this for x plus y to the fifth, and so on and so on and so on, but I'm not going to. But what I am going to do is I'm going to go back up to the very top right here and write the following over here. I also have x plus y to the first power, which is just technically x plus y. And we can even go one step further before that, x plus y to the 0. Doesn't matter what x and y are equal to, so long as they're real numbers. Any real number raised to 0 power, with the exception of 0 itself, the answer is going to be equal to 1. Now, the question here is, again, leading back to what I was saying, this is about binomial expansion. All of these guys right here are going to be examples of binomial expansions. And by binomial, I mean that the inside, you can see that there are two parts right here that makes up a binomial. And if I raise that binomial to some power, I would like to know what is it equal to without having to do all that extra work. Now, for example, what if I said I want to find out what is x plus y raised to the 99th power? You can obviously see that that's going to be a lot of work. There's going to be a lot of terms in between. So I'd like to find an efficient way to actually solve for this. Or more specifically, what if I want, like, say, the 50th term, the middle term of all of this? What is that going to be then? So the first thing I want you to notice is that let's go ahead and take this example for time being, okay, just as kind of like a model. You'll notice that there is a pattern that's being generated here that's easily followed. The first term, that's x to the 4th. Second term, that is x to the 3rd times y. Third term is x squared y squared. And then the fourth term is x times y to the 3rd. And the last term is y to the 4th. As the x is going to decrease for each term, the y, the exponent, is going to increase. So hopefully you can kind of see that here. You have x to the 4th, x to the 3rd, x to the 2nd, x, and then nothing. And then whereas for the y, you get y squared, y to the 3rd, and y to the 4th. Now, that is one pattern that is going to definitely help us out to figure out what this binomial expansion is. In addition to that, you'll notice that if you look specifically at the exponents, right? Here you have 3 and 1. Here you have 2 and 2. Here you have 3 and 1. And here you have 4. And technically, I guess x times x to the 0. And then you have y to the 0 over here. If you look at the exponents carefully, you'll notice that their sum is always going to be equal to whatever the exponent is going to be for the binomial expansion. Look at the previous example after that, before that. Here you have x to the 3rd, right? So that's the 3rd power because this is a cubic function. You have x squared times y, so that is going to give you x squared times y, so that is going to be a 3rd degree. This guy right here, that's also a 3rd degree, and this guy right here is also a 3rd degree. So that's kind of nice because that's going to help us out actually quite a bit. So as of right now, we know that for the binomial expansion, each term, the exponents are supposed to be equal to the sum of the power. So that's nice. So there's really only one thing that we really need to solve for. How do you solve for the coefficient of each part? Okay. So meaning, how do we get this number 3? How do we get this number 3? How do you get this number 1 right here? How do you get this number 2? And so on, and so on, and so on. Well, this now is going to be the interesting part because for some of you guys, you might have seen this in the past. And this is going to look somewhat familiar then. Let me, for the time being, go ahead and strip away all of the variables and write out the coefficient each time. X to the 0, right? The very top right here, this guy right here, the coefficient is just 1 because there's just one term. We have x plus y to the 1st power. That's going to be the coefficient of 1 and a coefficient of 1 because it's just x plus y. For the next one, x plus y quantity squared, the coefficients are going to be 1, 2, and then 1 because there are 3 terms and you can see the 1, 2, and 1. By the way, if you're not seeing the ones, this is just going to be saying write the 1 in front multiplied by x squared and write the 1 in front multiplied by y squared. Let's keep going, one more, or maybe a couple more. If we have x plus y raised to the 3rd, if I write out all of its coefficients, that's going to be 1, and then 3, and then 3, and then 1. And then finally, if we write the next one right here, that's again the coefficients for x plus y to the 4th. You can see that it's going to be 1, and then 4, and then 6, and then 4, and then 1. Now, again, to some of you guys, this might look a little bit more familiar, and this is what is known as the Pascal's Triangle. Okay, so Pascal's Triangle. And that's what's actually going to help us figure out what the coefficients are for this binomial expansion. The way the Pascal's triangle work is that you can see that if you sum any two consecutive terms, that'll give you the term below. So for example, the 1 plus the 3 right here, that gives you the 4. The 3 plus the 3 will give you the 6. And then 3 plus the 4 will give you the 1. So what that means is if I want to find out what is happening at x plus y to the 5th power, then that means, according to the Pascal's triangle, well, I'll first start with the 1, and I'll start with the 1 over here on the sides. 1 plus 4, that's equal to 5. 4 plus 6, that's equal to 10. 6 plus 4, that's equal to 10. And 4 plus 1 is equal to 5 then. So if I were to just kind of like put it all together, then my x plus y raised to the 5th, the expansion, is going to be the following. X to the 5th plus 5 multiplied by x to the 4th times y, because x to the 4th, we go down by 1 degree for x and go up by 1 degree for y. And then plus 10 times x to the 3rd, y to the 2nd, plus 10 times x squared times y to the 3rd, and then plus 5 times x times y to the 4th, and then finally plus y to the 5th. So that's how it's going to match up. That's this guy right here. That's the coefficient here. That's the coefficient here. That's the coefficient here, over here, and over here. Well, there you go. We got the binomial expansion then. Well, this is somewhat nice for the most part, but unfortunately, math does get a little bit more complicated. And, I'm always here to throw those what-if questions, and if not, somebody else will. The what-if question is then, well, what if I want to figure out what is, again, the 50th term, okay, of x plus y raised to the 100th power? Well, you can see how this could be complicated because if you want to use the Pascal's triangle, you're going to have to build all the way down to the layer that is going to be representing x plus y raised to the 100th power. And that's going to take a long time, and that's what I want to avoid, okay? Well, it turns out, and the proof, again, maybe I'll leave it to your teacher in the future, whoever he or she might be. It turns out that this Pascal's triangle is then related to this n choose k thing that we actually was talking about earlier. So here's what I mean by that, okay? Again, let me go ahead and write out the Pascal's triangle in the first part, the first few parts. So that's 1, 1, 1. 1, 2, 1, and then we have 1, 3, 3, 1, and then 1, 4, 6, 4, 1. Okay. If you were to actually, look at it numerically, here is what you're actually going to get. And actually, let me kind of write this on the side too to help us out a little bit more. This was supposed to be for x plus y raised to the 4th. This is supposed to be x plus y raised to the 3rd. X plus y raised to the 2nd, x plus y just by itself, and then we have x plus y raised to the 0 power. Again, it turns out that for the Pascal's triangle, each one of these numbers can be written as a representation of the n choose k form. And in terms of how it works out, it's the following. Starting from the bottom to the top, because I think that's a little bit easier for you to see. The first one is going to be 4 choose 0, and then that's supposed to be equal to the 1 over there. Then the next one is going to be 4 choose 1, and the next one after that is 4 choose 2, and then the next one after that is 4 choose 3, and then the one after that is going to be 4 choose 4. So that's what it looks like right there. That's this guy, that's this guy, that's this guy, that's this guy right here, and then that's this guy right here. The previous row, you can see that as going to be 3 choose 0, and then we have 3 choose 1, and then we have 3 choose 2, and then we have 3 choose 3. The previous row above it is going to be 2 choose 0, and then we have 2 choose 1, and then we have 2 choose 2. And then one above that one, that's going to be 1 choose 0, and then it's going to be 1 choose 1. And finally, from the very, very top, well, that's going to be just 0 choose 0 then. Okay. Now, in terms of how obvious this is obviously not exactly that easy to see. But it's nice though, because now we can actually figure out a way to solve for what we want. You'll note that here, for example, if I look at again x plus y raised to the fourth power, and we look at the coefficient of what it's supposed to be, like 4 is equal to 4 choose 1 and so on, so on, so on, you can see that that is going to be kind of like related to, in fact, it is related to what's happening all the way up here. You have actually, wait. I think I went too far back. You know what? Let me just go ahead and write it over here then, okay? Here, let me just go ahead and write out the x plus y raised to the fourth as an expansion using these factorials, using these binomial expansions, okay? Now, x plus y raised to the fourth power, according to what I wrote from the very top over here, this is going to be equal to the following. That's x to the fourth, and then plus 4 multiplied by x to the third, y to the first, and then plus 6 multiplied by x squared times y squared, and then plus 4 multiplied by x times y to the third, and then finally plus y to the fourth. That's according to, if we wrote out everything, we multiplied everything out the long way. Okay? Now, if I wrote this in our n choose k form, you might be actually be able to see a pattern and then be able to solve for what we actually want. Okay, let me go ahead and first put a 1 in front of the x to the fourth and also a 1 in front of the y to the fourth. Now, according to my Pascal's triangle over here, the 1, the 4, the 6, the 4, the 1, right? That's located over here, over here, over here, over here, and over here. Let's rewrite that in the n choose k form. The first number, that is going to be 4 choose 0, x to the fourth, plus 4 choose 1, x to the third, y to the first, plus 4 choose 2 times x squared, y squared, and then plus 4 choose 3, x times y to the third, and then finally 4 choose 4 times y to the fourth. And right there, that is the key, because look, if you notice the numbers that you're using in the n choose k format, those are really just the exponents of the variables. So here, for example, you have 4 choose 1. 1 is a variable that's here, right? And then the 4, that is going to be the power of the binomial expansion. So then here, let's look at another part right here. That's going to be 4 choose 2. That's going to be 2 right here. Actually, here, let me write it out so then that way you can see the exponents in. This guy right here, that is the same thing as 4 factorial over 0 factorial times 4 factorial. This guy right here, that is going to be 4 factorial over 1 factorial, 3 factorial. And now hopefully you can see, yeah, look, you have an exponent of 1 and you have an exponent of 3. The 4 choose 2 in factorial form, that's 4 factorial over 2 factorial, 2 factorial. And again, you can see now that is going to be the exponents over here. And then we have this guy, which is going to be 4 factorial over 3 factorial, 1 factorial. And then finally, for the last one right here, according to our n choose k definition, that's 4 factorial over 4 factorial multiplied by 0 factorial. Okay. So how about this? Let's go ahead and do the following. Let me give you a brand new fresh example, so then that way you can kind of like absorb this all at once, so that it doesn't look like it's too overwhelming. Okay. Let's say that I have the following over here then, okay? Hopefully this isn't, you can kind of keep up with this, okay? Let's say we have a plus b raised to the 9th power, okay? Now, what I want to do is I want to write out the entire binomial expansion and see what that's equal to. Now, again, you can go ahead and multiply everything out using the long way, but we can go ahead and use the short way of this binomial expansion, and I'm going to go ahead and show you that right now. So here, I know the following. I know that there's going to be the first term, which is going to be a to the 9th. I know there's a second term, which is going to be a to the 8th multiplied by b. Then we have a to the 7th multiplied by b squared, a to the 6th multiplied by b to the 3rd, a to the fifth multiplied by b to the fourth, and then we have a to the fourth multiplied by b to the fifth, and then we also have a to the third multiplied by b to the sixth. A couple more, actually two more after this. A squared multiplied by b to the seventh. We have then a times b to the eighth, and finally the term that contains b to the ninth. So the sum of every single one of these terms, right, that will again give you the binomial expansion that you want. Now, those are going to be my variables, but in addition, you also need to know what are the coefficients, these guys over here, right? So that's where we're going to use this binomial expansion and the n choose k factorial and, apply it to all of this altogether. So the first part, if it helps you, again, think of this as b raised to the 0 power, and this guy right here is going to be a raised to the 0 power. And that's going to help you then write out what the coefficient is going to be. The coefficient of the first term is going to be 9 choose 0. The second one is then going to be equal to 9 choose 1. Okay, and the 1 right here is to indicate to the power of the first over here. Then the next one is going to be 9 choose 2. And then the next one after that is 9 choose 3. And then we have 9 choose 4. And then we have 9 choose 5. 9 choose 6, and then 9 choose 7, and then 9 choose 8. Okay, and then the last one, that's going to be 9 choose 9. Okay, now again, you'll notice that the bottom number k is going to be the same as the exponent that's in the second part over here. So you have 0, then you have 0, you have 1, you have 1, you have 2, you have 2, and so on and so on. So if you were to write out all of this, that will then be my binomial expansion that we're actually looking for. Okay, and just to kind of write out a few terms in terms of what that's actually equal to. Well, 9 choose 0, that is going to be 9 factorial over 9 factorial times 0 factorial multiplied by a to the ninth multiplied by b to the 0. Then we have the second part. That is going to be 9 factorial over 8 factorial times 1 factorial times a to the 8th times b to the 1st. And then the next one is 9 factorial over 7 factorial 2 factorial times a to the 7th times b to the 2nd, and so on and so on and so on. And again, you're supposed to add up every single one of these terms all the way to the last term right here, which is going to say 9 factorial over 0 factorial 9 factorial times b to the 9th then. Okay. All right. Let's try something that's not as nasty. Let's go ahead and do maybe something that's a little bit simpler, so then that is also easier to grasp. Suppose this time I want to expand the following. Let's say that we have 1 minus 2x multiplied, 1 minus 2x, and let's go ahead and say we're going to raise it to the third power. Okay, so I'm going to use this binomial expansion to figure out what that's equal to. So here we go. There are going to be a total of 4 terms in here, and the number of terms is always going to be 1 more than whatever your degree is. Okay, so the number of terms is equal to 1 more than the exponent. Okay, so this is what you're supposed to have then. You have 1 raised to the third, and then you have negative 2x raised to the 0 power. Then we have 1 squared times negative 2x raised to the first power. Then we have 1 to the first power times negative 2x to the squared. And then finally, we have negative 2x raised to the third power. All of these are going to be the monomials that we're going to have to add up in order to get our binomial expansion. So those are going to be the variable parts then, okay? Now we also need to multiply them by their coefficient parts. And the coefficient parts, again, thinking of the pattern that we just did to make it a little bit easier, the first part is going to be 3, choose 0. The second part is going to be 3, choose 1. Then it's going to be 3, choose 2. Then it's going to be 3, choose 3. So if I add up all these 4 terms, then that's going to be our answer. Okay. So let's go ahead and clean up each one of these guys right here. So 3 choose 0, that is going to be 3 factorial over 3 factorial times 0 factorial. And 1 to the third, that is going to be 1, multiplied by 2x negative to raise to the 0 power, that is going to be equal to 1. Then for the next part over here, 3 choose 1, that's 3 factorial over 2 factorial, 1 factorial. And then we're going to multiply that by 1 squared, which is going to be 1, multiplied by negative 2x. 3 choose 2, that's 3 factorial over 1 factorial, 2 factorial. And that's going to be multiplied by 1 times negative 2 quantity squared. That is going to be equal to 4x squared. And finally, for the last one, 3 choose 3. That's 3 factorial over 0 factorial, 3 factorial. Okay, and that is going to be multiplied by negative 2x raised to the third power. So that's negative 8x to the third power. Again, we're supposed to add them all up. So if we kind of put them all out together, let's see, just to make it fast, because I don't want to bore you with the grindy math part of it. Okay, that first one looks like it's going to be equal to 1. Okay, yeah, this guy's going to cancel out. And the next part, this one looks like it's going to be minus 3. That's because that's what this is equal to, multiplied by negative 2x. Actually, here, let's say plus 3 multiplied by negative 2x. And then the next one after that, that is going to be equal to 3 factorial over 1 factorial, 2 factorial. That is equal to 3 again, and then multiply by 4x squared. So that's this part over here. And then the last part, that is going to be equal to 1. So that's 1 multiplied by negative 8x cubed. Okay, so finally just writing them all out. So your answer is going to be 1 minus 6x and then plus 12x squared minus 8x to the third power then.